Hello, and welcome to The Explainer. Today, we are going to crack the code on a huge piece of algebra, solving quadratic equations. And you're going to be surprised at just how simple the key to all of it really is.
So, have you ever seen an equation like this and just felt your brain freeze up a little bit? Yeah. It pops up everywhere, looking all intimidating like some kind of complex puzzle. But what if I told you there's one single key that can unlock it? Every single time. That's right. In just the next few minutes, we're going to hand you that key. And you won't just be memorizing how to solve these things, you'll actually understand why it all works. So, let's go find that key. Okay, Section 1, the quadratic puzzle. Before we can use the key, we've got to understand the lock, right? So what exactly is a quadratic equation? This is its standard form. Now, those letters, A, B, and C, don't let them scare you. They're just placeholders for numbers. We call them coefficients. The only really important rule here, A, the number in front of the x squared, can't be 0. I mean, think about it. If it were, that whole x squared term would just disappear and poof, it wouldn't be quadratic anymore.
All right, so you get the puzzle. Now it's time for the key. And believe me, it's this special little value with a very, very cool name.
Say hello to the discriminant. You'll often see it shown as that little triangle, the Greek letter delta. And this is where math gets really elegant. You see those letters, A, B, and C? They're the exact same ones from our original equation. You literally just take those numbers and plug them right into this simple formula.
Now, this is maybe the most important takeaway of the whole explainer. The discriminant isn't just some random calculation. It is the decision maker. It's the boss. Before you do any other math, you find this value. Because whether it's positive, 0, or negative, it tells you exactly which path to go down. It's your personal GPS for finding the solution.
So since delta can only be one of three things, positive, 0, or negative, it basically gives us three possible paths. Let's walk down each one together. Let's start with path number 1. This is probably the one you'll run into the most. It's what happens when your calculated delta is a positive number. You know, anything greater than 0.
When delta is positive, here's the deal. You are absolutely guaranteed to find two different real solutions. And this big formula right here is how you find them. See that little plus or minus symbol? That's the secret sauce. It's what creates the two different answers. You just plug everything in and boom, your solutions pop right out.
Let's put it to the test with a real example. We grab our A, B, and C from the equation. We plug them into that discriminant formula. Okay, let's see. The result is 16. Since that's positive, our decision maker is telling us, hey, get ready, there are two solutions coming your way.
And when you run those numbers through the big solution formula, you get your two distinct answers. X can equal 1 and X can equal 3. Two different keys for one lock. Simple as that. Okay, so that's path 1. Pretty straightforward, right? But what about path 2? What happens when the discriminant isn't positive but lands smack dab on 0?
Well, when delta is 0, things actually get easier. Instead of two solutions, there's just one. A single, unique, real solution. And look at the formula. That whole square root of delta part of the big formula just vanishes because the square root of 0 is 0. So it all boils down to this super easy calculation, just negative b divided by 2a.
And the process is exactly the same. We take our new equation, find our A, B, and C, and plug them in. And look at that. Delta equals 0. The decision maker has spoken. We're on path 2, and we know to expect just one solution. So we use that nice simplified formula, which gives us 4 divided by 4. And the one and only solution is 1. One path, one answer. Done.
All right, we've covered positive and we've covered 0. That just leaves our third and final path. What on earth happens when delta comes out as a negative number?
Believe it or not, this is the easiest path of all. If you calculate delta and it's negative, you stop. That's it. You're done. There are no solutions in the world of real numbers. You just can't take the square root of a negative number in regular math, so the big formula breaks. Your work is finished. Let's just run this final example to see it in action. We plug in the numbers for A, B, and C. and we get -4. The moment you see that minus sign, you can just put your pencil down. Delta has told you everything you need to know.
The solution set is what we call empty. It just means there's no real number you could possibly plug in for x to make that equation true. Path 3 is a dead end, but the good news is Delta let you know that right away.
And there you have it. The 3 paths, all decided by one simple calculation. The code is officially cracked.
Look at this table. This is your ultimate cheat sheet. It sums up everything we just talked about. If delta's positive, 2 solutions. If it's 0, 1 solution. And if it's negative, no real solutions. That's it. That's the entire game plan every single time.
And that's really the most elegant part. The discriminant is more than just a step to memorize. It's a diagnostic tool. It reveals the nature of the problem before you even start solving it, giving you a peek into what's coming.
So with that, you now hold the key. What once looked like an intimidating puzzle is now a simple, predictable system. And it kind of makes you wonder, doesn't it? Now that you've seen how one elegant tool can make this problem simple, what other complex challenges out there are just waiting for the right key? Thanks for joining us on The Explainer.